The security of large IT networks in government organisations and large companies has been the subject of intense focus. By comparison, security of small and embedded devices has gone under the radar. My guest on ipXchange, Snyder, the CEO of Thistle Technologies, thinks that's a mistake. We're going to find out why she thinks that and what she thinks embedded device manufacturers can do about it. Welcome, Window, to ipXchange.
Thank you very much.
So it's lovely to be in conversation with you and to be able to talk about security, particularly because obviously you've founded a company, Thistle Technologies, which is providing security solutions to the embedded device industry, but also because of your long history in security technology. So many people will have come across you, but for those of our audience on ipXchange who have not, I wonder if you could just give us a bit of a picture of yourself, sort of how you've kind of become involved in security, the kind of roles you've had, and the organisations where you've performed those roles.
Sure. So prior to starting this company, I was the chief security officer at companies including Square, now known as Block, Fastly, Mozilla. I was the chief software security officer at Intel. I owned all the security and privacy features for iOS and OS X while I worked at Apple for not quite 6 years. I owned security sign-off at Microsoft for the Windows operating system for multiple releases. And prior to that, I was a software engineer on security critical systems, a security consultant, and a security researcher. So a long history in the security.
Yeah, absolutely. And does that even go back as far as like your university education? Was security kind of a theme that you were picking up, that you were studying there?
No, there was no there were no classes or even books
Right.
for
Okay. Yeah.
in
Absolutely.
the no, we were all kind of uh, evaluating systems based on our own experience and our own interest, trying to evaluate security mechanisms, understanding how one might circumvent them, and using that information to try and build more resilient systems. There was no course to go take, there was no degree to go get that was going to help you in computer security beyond, let's say, a traditional computer science course back then.
Yeah, absolutely. Well, that's fascinating. So, I guess in that time, you've got some insights into how well security has been implemented in embedded devices. So, not just those that are really security critical, so payment terminals and so on that you'll have come across at Square, but in embedded devices generally. And I wonder if you can sort of give us a sense of what you think the state of play is for security in embedded devices today.
Yeah, and there's a lot of work that we've done in general purpose operating systems that you'd find, let's say, in the data center or even on enterprise servers or workstations. And a lot of that security work hasn't made its way into devices. And I think that's a pretty significant problem because these devices have become more complex. Computers over time have become more widespread. So we've got complexity growing, we've got the way we're using them, and then they're tied to critical assets, right? Like they are tied to assets that have to protect human safety, or power and water, or telecommunications. And then they have all the same attack surface that you'd find in a general purpose system, but without the same investment in security. So over time, I was starting to understand the scale of the problem across the industry and how few of these devices have really gotten that kind of security investment. And I understand why this is the case, for having done some of this work at Apple and done this work at Square for those devices. It's one of those things that's hard to do right and really easy to get wrong. It requires a really specialized skill set. A lot of folks don't have that hardware security team in-house. And even if you do have that team, they have a very long list of things that they need to go do. So it's very difficult to prioritize this, which a lot of times the customer can't even necessarily see. So when you're up against things like the impact to your schedule or the impact to performance, or even whether or not you've got the right folks in-house in order to be able to develop these security critical components, it's it's easy to understand how they get delayed, right? But these kinds of low-level security capabilities are required when you consider that they're attached to public networks like the internet, that they are attached to systems that have high security requirements. And even as we start looking at consumer systems, they're the kinds of um, devices that we might initially think don't have high security requirements, like let's say a smart TV or something along those lines, they're still sitting on a home network and have access um, to the rest of the devices on the network, and they're in a more privileged position once they're compromised, right? So that person who breaks into your thermostat at home, they're not going to necessarily leverage that that access to change the temperature in your house, right? They're going to want to use that access to attack more significant systems, more interesting systems on the network. So that's why all of these systems, even in a consumer space, have to have a degree of security resilience. And so it's true in the enterprise. It's true, even more true when we start talking about industrial manufacturing or automotive or all these other systems that have their own security requirements. They have um, attack surface that's not protected in the same way that we've been protecting data center systems, or the kinds of systems you find on in the enterprise.
So the reason that this matters is not so much, you're saying, because of the embedded device itself. If we're talking, as you say, about something relatively small and low cost, like a thermostat for a home automation system. So the danger is not so much to that thermostat, but it's to all of the networks and assets that thermostat is connected to.
I would say that's true for consumer devices. Yeah.
Mhm.
Um, but some consumer devices actually do have a fair bit of information available to them. Like they might have access to medical information, or personal information, or be connected to additional systems for which they're storing credentials. So having a token that allows you to access, let's say, your Amazon account through a an Alexa enabled device, or having a system that um, is able to connect to other critical systems in your house, like your locks, your smart locks, or
Yeah.
security cameras. Yeah. But so for consumer devices, I think those have been ignored for sure. But for enterprise devices, they are unfortunately kind of a black box to the IT organization. And as a CISO, as a chief information security officer, I found that I had these devices in my environment for which I had very little ability to inspect, and very little ability to manage. And when there is a security issue, it's very hard to evaluate which of these devices are impacted, whether or not they've been compromised. Can I even reset them to a known good state? Are they still using my configuration, or have they had some sort of configuration inserted? Or are they running only the code that the developer shipped? Is it possible someone's able to insert their own malicious code into these devices? So all of those capabilities were a point of frustration for me as a CISO, because while I had that sort of control over the systems in the data center, the systems, the enterprise systems, even the workstations, these devices were kind of this unmanageable um, area of risk for the CISO.
And is there a problem here that the manufacturers of these devices themselves are working under the assumption that actually they're not really that big of a target, so security isn't that big of a deal for them, for their device, and even though they have a responsibility to the wider network that they're part of, that um, that somehow they can see that as someone else's problem. So then the less priority, less resource, less money, fewer staff are given by that device manufacturer to the security of their own device, because it just doesn't in the end matter as much to them as it does to perhaps the owner of that device.
I'd say, yeah, the symptoms, the incentives are a bit misaligned. Yes, the party that's going to
Mm,
feel the impact, the insecurity of the device, is not the same party that decides to spend money to make that investment to improve the security of the device. So that, yeah, a little bit of misaligned incentives there for one. But I would say also it's hard to do. So even if that device manufacturers that knows that they have security requirements that need to be met, they might not have that hardware security team in place. They might not have um, that existing security capability, and it's hard to do. It's a big investment, or traditionally it has been a big investment. This is actually one of the reasons that I started this company, is because um, it is hard to get started with some of this capability. Is there something that we can do to make it easier for folks to get these capabilities into their devices without having to build everything from scratch? Because what I was seeing was that overall, for the devices that were implementing this sort of capability, they were implementing it differently in every different development environment. It was all um, implemented from scratch in these different places, and then to different degrees of security resilience, because not everybody has, let's say, the security team that's equipped to build it to resilience. Because of course, building security features, you can build it to spec, and it will not necessarily be um, resilient from a from attackers, because getting the security feature built is a different thing than building it so that somebody who's actively trying to undermine it is not able to easily circumvent it. So those are actually two different skill sets. So you might have a team that can build a security feature, but not necessarily build it to the resilience that's required for this device. So for all those reasons, I think it's um, difficult for even a device maker who knows that they need to incorporate these kinds of capabilities. It's hard to get it done.
Absolutely, and that's in spite of the fact that, I mean, this is not, this security conversation is not completely new, even in the embedded industry. I mean, it's, for many years it's been, it's been bubbling away there in the background, um, and there are, multiple sources of security technology for embedded device manufacturers to draw on. I mean, there are security software providers. There are many security hardware providers, providers of secure elements and hardware security modules and so on, um, in the semiconductor world, and they provide software support for their products. So there is security provision there. You're arguing that it's either it's not complete, or it's not resilient enough, or it doesn't all come together into a complete security solution. What's your sort of diagnosis of the current provision of security technology for the embedded industry?
Well, sometimes it's all of the above. And I would say there are a lot of
Right.
silicon manufacturers who provide a really great security capability in silicon that you then need to go write software in order to be able to incorporate into your product. And it's the software that is the gap for those device manufacturers that writing that software to take advantage of that silicon capability is
And that
difficult.
software is not is itself, that's not available, or the development environment to enable them to produce that software is not sufficiently available from the semiconductor manufacturers.
For some of them. And some of them do have
Mm.
a good amount of software support, but then that next level is not present. So turning that support into the capability, the actual security feature. So let's start with something like a security element, and what you want to do is enable something like secure boot, right? You might have uh, the software capability that allows you to call to the security element to validate um, code, but then tying it together into the bootloader, making the decision about whether or not the validation has been complete, and therefore allowing um, the kernel to load, then eventually tying it into the rest of the execution chain so that you can have a single hardware root of trust that allows you to establish secure execution across all the binaries in the system. There's generally a piece missing, and there's a question of like, how do we get the key onto the system? So managing the keys used for firmware signing is also a part of this. Everything from the build
Yeah.
environment to deployment, update, all of it. They're all pieces that are required before you have a secure update, a secure boot solution that's tied into update, so that your updates are also able to be validated by the hardware, so that you're able to maintain that secure execution across updates. Um, and some teams have pieces of this in place. Some teams have all of it in place, but they had to build it themselves, or a huge amount of it. So creating a set of these capabilities for which development teams are able to like pick the part that they need for the systems, and some of them need all of it, and that's fine. Allows them to better take advantage of the security capabilities that they've already paid for in silicon, right? That like being able to leverage that work without having to make that massive investment. And for a lot of development environments, that might be a year of engineering time or even two. Um, so being able to get those capabilities in place really quickly allows them to better take advantage of the investment they've made in this hardware.
So right at the start of our conversation, you talked about the way in which the security provision in operating systems like Windows and Mac OS had been greatly improved over the years. Many of our viewers on ipXchange who are working in embedded device manufacturers, we're working in a Linux environment. How well provided for are they in terms of security on the Linux OS?
Well, Linux is fantastic, of course, in the data center. Uh, has a very rich security architecture to draw from. And same for the embedded capabilities as well. The challenge, no matter which operating system you're using, is being able to tie it into the capabilities from uh, the hardware components to the bootloader to um, uh, the OS, and then to the backend services that you need in order to support this, whether that's an update service or a management service, firmware signing, things like that. So wherever you may be in this development process, there's a significant amount of work required in order to get the full capability implemented. And that's one of the things that we're trying to relieve, that you might have hardware capability available from your, let's say, from your silicon manufacturer, or a silicon capability that you want to leverage. There might be capabilities on the hardware, on the board. There might be um, elements you want to take advantage of in the bootloader. Being able to tie it all together so that you end up with a system that incorporates secure boot, um, update that's tied into the firmware signing, so that you're able to validate that the hardware, the update is coming from where you expect it and nowhere else, and using that to maintain the secure execution chain across the entire process. That's the critical capability that would otherwise require a pretty significant development investment.
Absolutely. So you've diagnosed the problem there of tying everything together. Let's talk about Thistle Technologies. What have you sort of put together? How did you conceive of what Thistle Technologies would provide that would solve this problem that you've been diagnosing for us today?
Yeah, the core idea is to make it easy for developers to discover and identify capabilities that are appropriate for their project, right? They may need a different set of capabilities from one project to the next. Like maybe they've got secure boot, and it's actually update that is the critical capability that they need in order to get there. I know for some environments, for a lot of hardware devices, update has been um, a challenge, because getting to the degree of reliability for hardware devices that you're actually willing to ship an update of any sort, not just a security update, that's actually a really high bar. So for other kinds of software projects, if you've got an update out there and you've got, let's say, a 3 or 4% failure rate, let's take a web browser, right? That web browser can be restarted by the user, or the user can reboot their system, and for the most part get themselves back into a known good state, and carry on with the update. Whereas for a device, you end up in a situation where if it's deployed out in the world and there's an update and the update fails, it's a complete disaster, because it requires, let's take something like a cable modem router, that sort of thing, and you've got 100 million of these deployed out in the world, and an update, you've got a 1% failure rate. Well, that's 1 million devices that now need to somehow get back up. And then the solution is to take a USB cable, plug it into a computer, download the firmware update, and flash the device itself. And by the way, how did they even get that firmware downloaded in the first place when their internet was down? This is a million folks calling in and saying, my cable's down, my internet's down. And also that probably
Yeah,
doesn't work because they're probably got their phone over voice over IP. So
yeah.
it's kind of a harder. If we're talking about cars, it means it has to come back to the dealership for those kinds of failures. If it's a phone, it has to go back to the mobile store. This is actually where my trial by fire was with these firmware updates, working on these devices, right? That like
Yeah,
um,
yeah.
of of security, or sorry, tolerance for update failures was essentially none, right? So update has to be incredibly resilient, reliable, before we're even willing to ship an update of any sort. And that's not to say anything about, let's say, industrial manufacturing. If you do an update and there's a failure, that's real time lost on in the factory. That's just revenue that's gone. And if it's um, a medical device, right? That's patient care that's impacted. If it's a satellite, that device is just gone forever, right? The kinds of tolerance we have for update failure on devices is so different than we have in the software world, that update might be the barrier to getting all this capability in place. So updates kind of this like foundational technology. Without it, it's hard to build any sort of security resilience at all. And then being sure that you are able to validate that the update is coming from where you expect it to come from. That's kind of the next piece here, because a lot of the times when we see hardware compromised, it's through a firmware update that for which signature validation isn't being done properly. It's another one of those things, like I said earlier, it's hard to do right and really easy to get wrong. And there's so many different ways that it can fail. And being able to have a software validation mechanism that's rooted in hardware is the highest confidence that you can have, and getting the implementation right is critical. So that's another piece of it. So there's lots of different aspects that some of these environments might have a piece of this ready. Maybe they're really happy with their update mechanism and they want to move up to secure boot, right, to get that to that next degree of security resilience. We want folks to be able to identify all the different kinds of security capabilities that are available to them, evaluate what's appropriate for their project, and then really easily incorporate these capabilities into their project. So that's the core that we're building.
And can I ask how does Thistle Technologies do that? So is it do you provide it by providing ready-made software, custom software, a development environment? What is it that you're providing to enable your customers to do the security in a integrated and easy way?
Yeah, well, in addition to developer education, we're also building software libraries. We have a number of different platforms that we support. We're working closely with those hardware manufacturers to both support the board in a way that is really easy to incorporate into these developer environments, um, through the build tools that they're using, through the capabilities that are in every different developer ecosystem has their own set of tools that they're let's say um, uh, fond of using. We try to support the tools that these different environments are using, and just make it really easy to incorporate these libraries and then leverage our backend services to be able to get the entire capability going at once. Because yeah, if it's each piece here is otherwise a very large investment. So making it easy to get the entire capability at once is the goal.
And is it provided as a software as a service sort of package, or how does it work in terms of using your libraries?
Yeah, so there's a developer license for the tools that reside on the client. So um, uh, we have C bindings for some security capabilities for to leverage some of these libraries. We've got secure boot, other capabilities that reside on the device. Those are just a developer license. And for update or remote access or firmware signing, those are as you said, software as a service. Those are based on the number of devices that you've got deployed in the world.
And tell us a little bit about the hardware platforms that you currently support.
So we've got a number of platforms that are listed on our website, which is at thistle.tech. We're trying to support devices that we see that are very popular, but a lot of this is really customer driven and driven by our community. So we have a lot of community boards that are easy to get up and running. So a lot of folks, when they're prototyping something, they choose some of these kind of community boards. And so those are very easy to work with right out of the box. But if there's a board that you're working with that's not supported, definitely ask us, because it's really easy for us to bring up those new boards and support the project using the board that you've already chosen. We'd love to talk to you guys
And
about that.
yeah, no, that's good to know. And the boards that are sort of most commonly used today to work with your software, which what are we talking about here? Sort of Raspberry Pi, uh, that
Yeah,
kind of thing.
yeah.
Excellent. So in terms of the best way for people to evaluate and get involved with Thistle Technology software is to start off with one of those evaluation boards that you support and that they're already familiar and comfortable with, and then go from there.
That's a great way to get started for sure.
Okay, very good. All right, excellent. Well, look, Window, thank you so much for explaining Thistle Technologies and talking to us more widely about the embedded device security situation. It's been fascinating, really brilliant insight, and really appreciate your time. Thank you so much today.
Thank you.